I will be taking you through the topic of forces. Just on the slide that you see, we can see a man holding a bar of weights across his shoulders. That demonstrates that there is force acting there. There's a force acting on the man by the weight of the bar, which is pushing downward. And the man is lifting the bar, trying to lift it upward. So there's an upward force. So let me just take you through today's lesson. Today's lesson will focus on the following. I will define what a force is, and then identify different types of forces, and then differentiate between contact and field forces. Then I give you examples of each type of force, and then I'll end my presentation with some revision activities. Okay, what is force? A force is a push or pull that can change the motion of the object. As you can see here, the man is pushing against the table on the floor, and we say as he's pushing the table is also pushing against the man. So we say the forces exist in pairs. If one force is in one direction, the other force is opposing that force, it is in the opposite direction. Now, force can also make something move, stop, speed up, slow down, or change direction. Meaning, if you are pushing against an object, if an object moves, it means the force that you are applying is more than the force that the object is applying on you. Hence, the object will move forward. If you are pushing against an object and it doesn't move, however force you apply, it means the force that you are applying is being balanced by the force of the object. That is why the force is not moving. If the force was already in motion and then you push and then it speeds up, it means you have increased the forward direction of the force. If the force, something is slowing down, like someone is kicking a ball towards you, the person would have kicked the ball with a particular force. Now, if you stop it with your feet, it means you have slowed down the force. It means your force is greater than the force in which the direction the ball was moving. Also, the force can change direction depending, as I will illustrate later. Force is also measured in newtons. Okay, let's move on to the next slides. How do forces affect objects? They can affect objects in 5 different ways. The first one, a force can change the shape of an object. A force can move or stop objects. Forces can change the direction of an object that was already in motion. Forces can change the speed of an object. Right. An example of changing a shape is a baker uses a force on his dough to shape it flat. And then in this case, we've got 2 types of applications of force. I mean, the effects of force here. It is the effect of moving an object and also the effect of stopping an object. In this case, a man can push the lawnmower forward by pushing against the handle. So the lawnmower will move forward. A man can pull the lawnmower so that the lawnmower can stop. It means the man can actually stop or move the object. A man uses force to move a stationary lawnmower. And then a footballer uses force to change the direction. Somebody can kick a ball towards you, can actually change the direction and kick it the other way. So you are using force to change the direction of the moving object. And forces can also change the speed of an object. For example, here a cyclist can pedal faster. By pedaling faster, the cyclist will be using more force, so the bicycle will travel faster. Okay, there are two main groups of forces, two categories in fact. We've got what we refer to as the contact forces and also non-contact forces. Now the two categories are further subdivided in the following. Contact forces that we deal with in grade 9 are the frictional force, the tension force, the compression force. And then the forces that are non-contact, meaning that can actually exert their influence from a distance without touching the object, are called non-contact forces. And examples are gravitational force, magnetic force, electric force. Let's look now at the contact forces. The contact force that we are looking at here is a frictional force. The force that opposes the motion of an object is called frictional force. Now, an example here, a child is moving down the slope on a slider. If there was no frictional force, obviously the child will slide forever and not coming to a stop. Then there is also an elastic force or compression force. The force exerted by the stretched spring. We can stretch a spring, and then as we let go, the spring can contract, meaning there's what we call compression forces. I mean, if you stretch it, it is an elastic force, and then if we press the spring and make it smaller, we call it a compression force. In both instances, whether we stretch the spring or we compress the spring, the spring will actually have its own force, that one of expanding or contracting. And then there's a tension force. Now, a tension force is actually also another contact force. It's a force that is transmitted through a string, a rope, or a cable. It's different from what is called an applied force. An applied force is this man who actually be pulling this box without using a string. That would be an applied force, or pushing this box without a string. But if he pushes or if he pulls with a string, the force that is in the string or the cable of a lift, elevator, is called the tension force. Now, then the non-contact forces, meaning the forces that can act over a distance. Gravitational force, it's one of those forces. The force that pulls objects towards the earth. An example is an apple falling from a tree. If a bird is picking on a branch and then the apple falls, it will go down being pulled by gravitational force. And then magnetic force. If you have any magnetic material and then you bring a magnet closer to the magnetic materials, even before touching the object, the magnetic pull will actually attract the magnetic materials towards the magnet. So we call that magnetic force. Then we have what is called electrostatic force. Electrostatic force is the force between charged objects. An example is a charged balloon attracting pieces of paper. You can just blow a balloon and then rub it against your hair and then bring it closer to pieces of paper. Then the piece of paper will be attracted to the balloon and actually stick onto the balloon. Okay, here's the first activity. It's classifying forces. It is just revising what I've just talked about now. We are having a scenario, and then we are going to look at the force that is involved, and then we also describe whether the force is contact or field force. Here are the 5 scenarios. A ball is falling to the ground, and then you are pulling a wagon with a string. A balloon is sticking to a wall after rubbing. And then you apply brakes, slowing down a bicycle. You should also start thinking about what forces are involved there. Let us just look at those forces. A book falling to the ground, it will be the gravitational force. Pulling a wagon, it will be the tension force. A balloon sticking to a wall after rubbing, it will be electrostatic force. Braking or slowing down a bicycle, it's because of the frictional force between the wheels of the bicycle and the ground. Now you can always also categorize them if they are contact or field forces. Gravitational, tension, electrostatic, and friction. Let's just look. Okay, the gravitational force, therefore it is a frictional force. The tension force is a contact force. The electrostatic force, it is the field force. The friction is a contact force. Contact force, it means the force that is applied is in contact with the object on which the force is being applied. Let's look at the second activity. It can be like something like a multiple choice question, choosing the correct answer. Let's just go through all the statements. A force is best described as, then you choose an answer there. What unit is used to measure force? And then you choose an answer there. Which of the following is a field force? Meaning the other are contact forces. And then this other multiple choice, what type of force causes a magnet to attract a paper clip? And then you also choose there. Let us now look. So the answer there would be, a force is described as a push or pull. What is the unit to measure force? It is the Newton. Okay, which of the following is a field force? The gravitational force. It means friction, tension, and applied force are contact forces. What type of force causes a magnet to attract a paper clip? Obviously, it is the electrostatic force. Now, the last activity, match a term to a definition. You know, in our assessment, sometimes we get a matching question. Now we've got friction in the first column, magnetic, gravitational, and tension. And then in the second column, it would be the descriptions, magnet pulling a nail, dropping a stone from a bridge, resistance when sliding a box, rope pulling up a bucket. So let us look what matches friction. Obviously, resistance when sliding a box. It means friction, you get it when something is moving, sliding against the ground. The ground is trying to prevent the motion. So the answer, if you answer it there, it would have been 1B. It's just a mistake. The answer would be B here. And then the magnetic, the answer would be C. Just ignore the numbers in front. The answer would be C for number 2. The gravitational force, the answer would be A. These are just a mistake. It's a C here. Gravitational it's C. Magnetic, it's A. Friction, it's B. They're just mixed up. My apologies for that. And then the tension would be D. So the answer for A, friction, it's this answer is B. It was supposed to be there. It's B. The magnetic is pulling a nail. Gravitational is dropping a stone from a bridge. Tension, a rope pulling up a bucket. This concludes today's lesson. Thank you very much for coming, and also the teachers for supporting your learners. Thank you very much.
Thank you so much.